Welcome back to channel guys. I will open ETAB again. Mm, this is the class 3. In previous two classes, we see how to define materials and frames or properties and how to assign them. In class 2, we see how to define load patterns and how to assign them. And we have checked the model, no error in our model. Okay. Uh, and here we define in the load patterns. There is a floor finish plus ceiling plaster. Maybe you don't understand that, so I will repeat that again. I will show you what is the meaning of that. Here you see, this is my slab. Okay, in the middle this is my slab, and on the top, this is my floor finish level. This is layer of the floor finish because we do the tiling work. So before tiling, we use the mortar, that is sand, cement and sand paste and mortar, and then we put our tiles on that. So it has also a dead load. Okay, and there is a, on this slab at the bottom side we do the ceiling plaster for on the slab. If we are doing pop work, then we do not provide the ceiling plaster there. Okay, now I hope you understand this concept. This is my slab. On the above of the slab, this is my floor finish, and at the bottom this is ceiling plaster. Okay, I will open my tab again. So uh, now this is the third class. We already analyzed our model. There is no error in our model. So now these things are okay. Then we can do the run analysis. Here is the option of the run analysis. Okay, just click on it, and here you see at the left side the model is running. Analysis is running. Just wait. You need to wait for a minute because the running is in the progress. Here you see at the left corner. Here you see the run analysis is done. Here you see the shape of the slab. Okay. After analysis, there are a lot of checks we need to do. So first check, here is the in the display option. Here is undeformed shape. You can go from here as well, or here is the we have the option. Here you see show deformed shape. From here you can also check. So I will just click on it, and here you see this is deformed shape. This is a check for the slab. Okay, and we will check for the combo because we added the load combinations. That is factor of safety 1.5 into dead load plus live load. So we will check for it. Just select this combo, and here is the option of draw contours on object. Click on it, and here you select displacement huge head. Okay, and then just apply, and okay. Here you see the deformed shape of the slab, and here you see the minus 5.20 is the maximum deflection of the slab. That's mean it is going in the downside. Okay, it's showing the some deflection, and maximum deflection in this all the stories, that is maximum deflection is minus 5.20. Okay, so it is okay. It not go beyond 20 mm. This is the check for the slab. It not should go beyond the 20 mm or the span by 350. Okay, this is a 4 meter span, that if you divide by the 350, it should not be 350 or the 20 mm, whichever is less. Okay, so maximum deflection of the slab is minus 5.20 mm here. So you can check for the slab right, like this. You can check here as well. So I just show you. I just click on this window, and I will go again. Show deform shape combo. I will take 1.5 into dead load, draw contours, displacement user, apply, and okay. And here you see the deflection. I'm on the third floor right now. That is my terrace floor. And here you see the my maximum deflection of this building. Maybe this slabs showing the maximum deflection. I will just come downside. On the second floor, here you see, if I bring arrow here, you see the value of UZ minus 5.2. Okay, on the second floor, you can see the maximum deflection in the slabs. Okay, so this is how you can check for the slab. And here is the option of the show deform shape. Just click on it and it will go on. Okay, now I will check for the bending moment and shear force. So I am here in the 3D view and here is the option. Here you see display frame, here Spandler link forces. You can also uh, see from here as well, but I am doing from here. Check for the combo 1.5 dead load plus live load, and when we are checking for the bending moment, then we need to select the moment 33. Okay, just select the bending moment 33 and just click apply and okay. And here you see all the bending moments of the beams it is showing. You can check here as well. Just come on this window and click here, check for combo moment 33, apply and okay. And here you see here you can see the bending moment of each beam. I am on the first floor right now. I just click on any beam and right click on it. Okay, then you can see the shear V2 moment and the deflection. Okay, so bend moment is maximum is minus 33. If you solve this manually, you can you will get this value. Okay, so bending moment maximum on this beam is minus 33. So you can check for each and every beam which you want to see. I just click on this beam, right click, and you can see the values, moment and shear. Okay, now I will check for the shear force. I will go it again and here combo, and for the shear force always remember we need to select the shear 2 2 for the bending moment moment 3 3, and for shear force shear 2 2. Okay, just apply and okay. So here you see the shear force diagram. Just click on any beam and you can see the shears and moment and the deflection as well. Okay, so this is how you can check, and you can check for the 3D as well, and here on the plan proper on particular floor as well. Okay, so then you can check for the, here is the option of the axial force. You can check for the axial force as well. Axial force is the column forces. So if you select the axial force and click on apply and okay, and here you see you can't see the values here. So I will click show values. I will go again. Here I will select axial force combo 1.5, and here I will select show values at controlling stations on diagram, apply and okay. So it is showing here. Actually I want to see in 3D, so I will click on this window and I will just click axial, apply, okay. So here you see on the each corner of the columns it is showing the axial force. Here you see it is showing the axial force. Okay, this is how you can check the axial force in the column. Or here is the option of display support spring reactions. That's when you can directly see the complete load on the column is coming on the base. So because of that load, you can design the foundation. So what I will do, I just select this tab. I will come to the base level. Here you see I am on the base right now, and I will select this option, display supports 1.5 dead load plus live load, and always remember to select the FZ, and you can do the tabulated or arrows, apply and okay. So here you see the FZ value. Here you see the FZ value 492.282. So this is the load on this column is coming at the base. Okay, here you go. Check the FZ value 790.28. This is the FZ value. So this is the total column is coming on this total load is coming on this column at the foundation. So by using this value, you can design your foundation. Okay, here you can also see that values. I just click here and I will click. Sorry. Here I will select this display support reactions. Apply. Okay. So here you see at the bottom of the each and every column, the load is coming on that particular columns. Okay. Here you see the FZ value. Here you see FZ value. Check the FZ value for 746, 746, 492. So on this column, load is coming is less as compared to these columns. So by seeing this value, by using this value, you can use you can design your foundation. Okay. So these are the mainly checks. Then then how you can know my columns and beams are safe or failing? So you can check that. Here is the option of the design. Okay, go to design and concrete frame design, and there is option of view revise preferences. Just go into it and select here your IS code is IS456 2000 or not. If it is something different, then choose and select IS456 2000. Okay, and just select OK. Then go to design again, concrete frame design, and here you see select design groups. Just go into it and select on all and add, and just click OK. Again go to design, concrete frame design, and select design combinations. So these are the two combinations we already designed. So just add them here and just click OK. And again go to design, concrete frame, and start design check. So it will check your whole structure and it will say which columns and beams are failing or not. Okay, I will click here and I will check for the 3D. I will go to design, concrete frame design, and start design check. So it will check all the structure by using that all load combinations we are saying, by what kind of load we applied. So here you see it is showing the values, lot of the values. And if there is a, you can see if your all are the pink colors, if there is a red in color, then you can understand that columns or beams are failing. Okay, but from here we did not understand because here is a lot of values and lot of columns and beams. So there is something failing or not, how you can check? Go here design, concrete frame design, and here is the option of verify all members pass. Just click on it and it will show you all concrete frame pass the design check. That means our structure is safe and not any column or beam is failing here. Okay, so our structure is safe. ETABS tells us all concrete frames pass the design check. Okay, so this is how you can design the structure, assign the loads, assign the combinations, and then you can run the analysis. And by using that, yeah, you can understand your structure is failing or not. Okay, so this is the all about the first first structure. And you, I think, I hope you guys understand this all concept. So I will end the lecture and we will see in the upcoming lectures and we will start the project too. Okay, you can save the file from here. Just click on the save and stay tuned for upcoming videos, guys.